Hello Gems! Welcome to another video of ACE series. This is one of those typical videos that I'm filming while my internet is still down. I don't know why I have developed this connection with you all within this short period, even as a small creator, that whenever I don't upload, I feel uncomfortable, okay? Anyways, the topic that we are going to discuss today is waves. Yay, Bits Goa, right? So yeah, let's begin without a further ado. So alright, here we have question 1, 2, 3 from the super easy category. So in question 1, which was asked in 2014, you are asked for the wave velocity. The equation of the wave is also given. Okay, straightforward question, a formula based question, because we know that wave velocity is given as omega by k. Okay, coefficient of t divided by coefficient of x, right? Now I am not going to multiply this pi by 2 inside, because at the end of the day I know that I am going to take the ratio. Right, so anyways that will cancel out. Okay, so I'm just going to write a coefficient of t, which is 50, divided by coefficient of x, which is 1. Okay, so the correct answer will be 50 in whatever units it was mentioned in the question. Okay, so 50 is the correct answer over here. Let's come to question 2 now. Question 2 has given you mu. Mu is the linear mass density of a stretched string. Okay, the equation of the wave on that stretched string is also given. You are supposed to find the tension. Again, a formula based question, okay, because we know that v equals, on a stretched string, the velocity of a wave equals under root t by mu, right? So from here you can find t, and for v you can use omega by k, right? So substitute over there. So you have to find t, right? So v square into mu will give you t, right? V square will be omega by k the whole square, omega by k the whole square, 60 by 1.5. So 60 divided by 1.5, 15 4s are 60, right? So that will be squared, so 40. So 1.5, 40s are 60, right? So 40 squared into mu, mu is 3 into 10 to the power 4. Okay, and this will be the tension, right? So that will be 16 into 10 to the power 2. This is 10 to the power minus 4, right? So yeah. So this will give you 16 into 3 into 10 to the power minus 4. 16 3s are 48. So that will give you 48 into 10 to the power minus 2. That will be 0.48. Okay, so 0.48 is the correct answer. Now in question 3, we are given a special case of our Doppler's effect, wherein the observer is at rest and the source is moving with a constant velocity v. Okay, we are supposed to find the correct plot of n versus t, where n is the frequency and t is the time. Okay. Okay, I'll tell you the story how it goes. So you have your observer over here and source over here. Okay, so in the first half of the journey, the source is going to approach the observer. Okay, first half, source is going to approach the observer, and in the next half, the source is going to part away or separate away or move away from the observer. Okay, so the question is the same: find the correct plot of frequency versus time. Okay, you can pause and try it. It's a very good one. So let's do it. Now the thing to note over here is that the Doppler effect makes it very clear that your frequency, the apparent frequency, only depends on the values of your velocities, right? The velocity of the observer and the velocity of the source, right? It does not depend on any other factor. Of course, it depends on the condition whether the two things mentioned, the observer and the source, are approaching each other or they are parting away from each other. Okay. So here we'll have only two unique frequencies, right? Why is that so? First of all, note that time is not a factor. As I mentioned, the two factors are, one is the velocity of the source and observer, and the second one is the condition whether they are approaching each other or they are parting away from each other. Okay, so time clearly is not a factor in frequency, for change in frequency. Okay, so here in our case, we'll only have two unique values for our frequency. And how is that? First in the case of approach, and second in the case of separation. Okay, only two unique values. Okay, so first is the approach value and second is the part away value or the separation value. Okay, so either it's option C or option D. Okay, a frequency is not dependent on time. Okay, so approaching frequency 1 and second frequency is the parting away frequency. Now we just have to think which one is bigger. And now it's obviously clear that the frequency which is approaching us, when the source is approaching us, that time the frequency will be more, right? That time the number of waves reaching us will be more, right? So the correct option is, in the first part the frequency should be more, okay? So initially frequency should be more and afterwards the frequency should decrease, right? When the source is moving away, the number of waves reaching us is less, right? So option D is the correct choice. First, the frequency, sorry, is more, and when the source is parting away, the number of waves reaching us is less, so hence the frequency is less. Okay, I hope that is clear. Let's move to the next question now. So question 4 from 2005, this is from the easy category now. So in this question you are given frequency and velocity of a wave. You are supposed to find how far are 2 points which are 60° out of phase. Okay, so it's a conceptual one, think through it. First of all, you should know the relation that for a phase difference of 2 pi, the length which is required is lambda, okay, where lambda is the wavelength, or you can state it this way, that 2 points at a distance of lambda, where lambda is the wavelength, 2 points at a distance of lambda has a phase difference of 2 pi. Okay, I'll repeat it. 2 points at a distance of lambda, where lambda equals wavelength, have a phase difference of 2 pi. Okay, you want a phase difference of 60°, right? That will be pi by 3 radians. Okay, so for this you want to find the length, how far, right? So for this you want to find the length, so you can just cross it, linear relation, right? So it will be that length, whatever that length is, that will be lambda into pi by 3 divided by 1 by 2 pi, right? Pi and pi will get cancelled, and now you are supposed to know the value of this lambda. You can find this lambda using this data. Okay, so you can write lambda equals v by f, right? Lambda and f are inversely proportional, or you can see that f lambda equals v, right? So lambda equals v by f, right? So v by f, just substitute those values, v by f 500, so we can directly substitute it over here, 360 by 500, so that will give us 1 by 6. Now 6 are 36, this and this will get cancelled, 1 by 6 by 50, right? 6 by 50, that will be 0.12, 0.12. Okay, so 0.12 is the correct answer. You can calculate it, the answer will be 0.12. Okay, over to the next question. Okay, question 5 over here from 2013. In this question you are given the equation of a wave. It is also given that the maximum velocity of the particle, maximum velocity of all the particles in this wave equals 2 times the velocity of the wave. Okay, you are supposed to find the value of this lambda. The approach is quite straightforward. You are just going to exploit that data, right? First of all, you should know that wave is nothing but just a collection of millions and millions of particles just doing SHM, right? As far as your syllabus is concerned, or to say it in a more precise way, a plane progressive wave is just a collection of millions and millions of particles just doing SHM, right? So in place of this maximum particle velocity, I can just plug in the value of maximum velocity in an SHM, because after all a particle is just doing SHM, right? So in place of this maximum particle velocity Vp max, we can just plug in the value of maximum velocity in SHM, which is a omega, right? Where a is the amplitude of your SHM, okay, and omega is the angular frequency, okay, and that will be equal to 2 into velocity of wave. Velocity of wave, you can write it in general terms, omega by k. Okay, this and this will get cancelled, omega is same. Okay, and now the amplitude, what will be the amplitude of that SHM? The amplitude of that SHM is nothing but the amplitude of wave itself, right? Because the amplitude of the SHM is reflecting the amplitude of the wave. Okay, so amplitude over here is x naught, and here we are left with 2 by k. Now k value is coefficient of x, right? 1 by lambda. No, it's 2 pi by lambda. Okay, so since we considered the value of omega as 2 pi nt and the value of k as 2 pi, you have to multiply this 2 pi inside. Okay, the ratio thing is not working, we are not cancelling this over here. Okay, so now, so you have multiplied this 2 pi inside, and the coefficient of x is 2 pi by lambda. Okay, so 2 pi by lambda, that goes on top. This 2 and this 2 will get cancelled, and you'll get the value of lambda as pi x naught. Okay, so option D, pi x naught, is the correct choice. Over to the next question. Okay, question 6 over here from 2016. In this question, you have a string of length L and with original frequency F. You have cut that string into 3 pieces with length L1, L2 and L3 respectively. Okay, these are their respective frequencies F1, F2, F3. Okay, you are supposed to find a relation between this original frequency F and F1, F2 and F3. A very simple question because the only thing that you are supposed to know in order to solve this question is frequency is inversely proportional to length. Okay, this is the only thing which you are supposed to know, and the question is done. You can write frequency equals k by L, right, where k is some proportionality constant. Now since this string was cut into 3 pieces, we can write L equals the original length equals L1 plus L2 plus L3. Right, if you add the length of this 3 pieces, it will give you the length, the original length. Right, now write this L in terms of F and K. Okay, write this L in terms of F and K. So you can write L equals K by F, right, K by F. So K by F, where F is the original frequency. Okay, L1 you can write it as K by F1, right, K is a constant, right, K is the proportionality constant. L2 you can write as K by F2, and L3 you can write it as K by F3. So you can cancel this K throughout and you'll get the relation, which is 1 by F equals 1 by F1 plus 1 by F2 plus 1 by F3. So option B is the correct choice. Okay, I hope this is very simple. The approach is very easy, right? Let's move to the next question now. So question 7 over here, this was asked in 2018. In this question, you are given 10 tuning forks. A pattern is followed over here. Tuning fork 1 and 2 produces 4 beats per second. Also tuning fork 2 and 3 produces 4 beats per second. This pattern is followed. Okay, 3 and 4 will produce 4 beats per second. 4 and 5 will produce 4 beats per second again, and the pattern is followed till the 10th tuning fork. Okay, you are given that the frequency of the 10th tuning fork is equal to twice the frequency of the first tuning fork. Okay, so you are supposed to find the value of F10 and F1. F10 is the frequency of the 10th one and F1 is the frequency of the first one. You have to find those frequency. Okay, we are supposed to decode a lot of data over here, so let's get started. So tuning fork 1, let's assume its frequency to be n. Right, now since it produces 4 beats per second with the tuning fork 2, the difference in their frequencies should be 4, right? So the frequency of the second tuning fork can be n plus minus 4, right? Correct, the difference in their frequencies should be 4, right, in order to produce 4 beats per second. Now going to the third one, the second and the third one also produce 4 beats per second. So again follow the same pattern, n plus minus 8. Okay, you can see that the difference in their frequencies is again 4. Okay, so this goes on till 10, and at 10 we'll get n plus minus 36, right? Following the same pattern, you can see the table of 4 over here. After 1, okay, after 1 there are 9 forks, right, 9 forks. So 4 9s are 36. Okay, after 1 the table begins from here, right, 4 8 12. So after 1 there are 9 forks, so 4 9s are 36. Okay, following the pattern. Now you can see that the frequency of the 10th fork is 2 times the frequency of the first one, which means frequency is increasing, right? Frequency of the 10th one is 2 times the frequency of the first one. Frequency of the 10th one is more, right? So this minus sign is not justified, right? It cannot be minus, it should be plus, because we know that frequency is increasing. The frequency of the 10th one is more. Okay, so it should be plus. Okay, the frequency is going on increasing. So that was something you should have decoded from this. Okay, so now just substitute the values over here. Frequency of the 10th one, which is n plus 36, equals twice the frequency of the first one, 2n. Okay, so you will get the value of n to be 36, right? 2n minus n equals 36, and this is nothing but the frequency of the first one, right? Frequency of the first one was n, right? And frequency of the 10th one, which is 2 times this, will be 72. So option D, 72 36 F10 F1, right? 72 36 is the correct choice. Okay, I hope the approach is clear. We just found out the pattern. We considered the frequency of 1 to be n, and then plus 4 plus 8 plus 36 plus minus actually, and then we noticed that the frequency was increasing, right? The frequency of 10th one was bigger, so we only considered the positive sign. Okay, and then we just substituted using this, right? Just substituted this values using this relation, and then we found out the value of n. So simple, right? Let's move to the next question now. So question 8 over here, asked in 2009. In this question, you have two tuning forks which produce 6 beats per second, okay, in their natural frequency. You also have two resonant tubes closed at one end, okay. So this will give resonance, these two tuning forks will give resonance when the length of this one is 24 centimeter and that one is 25 centimeters. This is used respectively, okay, A for A, B for B. You are supposed to find the frequency of A and frequency of B. Again, the same logic we are going to use. Frequency is inversely proportional to length, right? First of all, you can see that the difference in their frequency should be 6, right? Because they produce 6 beats per second. So difference in the frequency of A and frequency of B should be 6. So option A is not the correct answer. Option B is also not the correct answer. The difference is only 4 over here. So the difference should be 6. Okay. So either C or D. So now, so we can consider one of them as n and the other one as n plus 6, right? We can consider one as n and other one as n plus 6. Okay. Now the question is who to consider n and who to consider n plus 6. Come back over here. Frequency is inversely proportional to length. So larger length implies smaller frequency. So you can see over here 25 centimeters for tuning fork B, which means we require n, right? This frequency of B will be n. Why? Because larger length, lesser frequency. Lesser frequency is n, right? So FB, frequency of B will be n, frequency of A will be n plus 6. I'll just repeat that. You can see frequency inversely proportional to length. So larger length, 25 centimeter, bigger than 24, of course. So lesser frequency, right? Lesser frequency, lesser among these two is n. So n goes for B, okay, and n plus 6 for A. So again, use that logic. So I'll just take the ratio, frequency n plus 6 divided by n, frequency of A divided by frequency of B equals length of A divided length of B divided by length of A. I just use this, frequency of A divided by frequency of B equal length of B equal by length of A. Okay, inverse relation. You can see that inverse relation. Now just solve this. Length of B is length of B 25 and 24 over here. So 24n plus 24 into 6, that gives you 6 4s are 24, 6 2s are 12, 30 14, 144, 144, and that will give you 25n. So you can see that the value of n is 144 and the value of n plus 6 will be, the other one is n plus 6, right? So 144 and 150. 144, 150, option C is the correct choice. I hope the approach is very clear. Okay, let's move to the next question now. By the way, the bits type of question, the question from bits section are very favorite of your BITSAT. I don't know why. Maybe because the exam name is BITSAT. Lame. Over to the next question. Question 9, an old BITSAT question from 2006. In this question, you have an open organ pipe, which is open at both the ends, of course, and has a length L. Frequency is its frequency is given as n. Okay, you are going to seal half of the portion of this open organ pipe to convert it into a closed organ pipe. Okay, an organ pipe which is closed at one end and has a length of L by 2. The frequency of this pipe is f dash. You are supposed to find the value of f dash in terms of n. Okay, so let's dive straight into it. So f dash will be given as 1 by 4L. This is the formula for frequency of a closed organ pipe. Okay, so 1 by 4 L. Now L, what is the length of this pipe? It is L by 2, right? So L by 2, that will go on top, into V. The speed is of course not going to change, right? Whether in this case, whether you consider this case or this case, speed is not going to change, of course, right? Speed depends on the medium. The medium is anyways not change. So speed is not changing. So here you have f dash is equal to 1 by 2L into V, and here also you'll have the same thing. You can see that. Okay, so let's write it for this one. So frequency over here is n, right? So n is will be given as 1 by 2L. This is the formula for our open organ pipe. Okay, so 1 by 2L into V. Okay, the length is L over here. So yeah, substituted. So you can see that both of this are equal, right? N equals f dash. So the answer is B. F dash equals N. Okay, such a simple question, right? So over to the next question. So question 10 over here. In this question, you are given that the fundamental frequency of an open organ pipe is 300 Hertz. The first overtone of open organ pipe equals first overtone of the closed organ pipe. Okay, the velocity of the sound is also given. You are supposed to find the length of the closed organ pipe. Okay, I hope you are not among those who get confused with this open and with this overtone and harmonic thing. Okay, if you do, here's something for you. Okay, those people who don't get confused can skip some seconds. Okay, so here we'll consider the overtone, and here we'll consider the harmonic. Okay, so here we'll consider open organ pipe and closed organ pipe. Okay, so for an open organ pipe, all the harmonics are present, right? So for nth overtone, it will be n plus 1 harmonic. Okay, for nth overtone, it is n plus 1 harmonic. Okay, first overtone means second harmonic, third overtone means fourth harmonic for a open organ pipe. Now in case of closed, only the odd harmonics are present, right? So for an nth overtone, the harmonic will be 2n plus 1, only the odd numbers. Okay, 2n plus 1. Okay, so for first overtone, it is the third harmonic. For second overtone, it is the fifth harmonic, only the odd numbers. Third overtone, seventh harmonic. Okay, I hope the idea is clear. Now let's solve it. Okay, so first overtone of your open organ pipe, first overtone means second harmonic, right? First overtone, second harmonic. So 2 times the fundamental frequency of the open organ pipe, right? Equals first overtone of your closed organ pipe. First overtone of your closed organ pipe means the 2n plus 1. So third harmonic. First overtone, third harmonic for the closed organ pipe. Okay, so 3 times the fundamental frequency of the closed organ pipe. Okay, so now I think you can substitute the values. This will be 2 into 300, 3 into here you have to plug in that formula 1 upon 2. Now this is for closed, right? So it will be 1 upon 4 length of the closed organ pipe into velocity. Velocity is 330, right? So 330. So you want the length of the closed organ pipe. So length of the closed organ pipe will be given as 3 into 330 divided by 300 into 4 into 2. Okay, you can cancel this 10s are 11s are this will be, okay, the answer that you will get is, this will be 33 divided by what is this? This is 40 and 80. Okay, so 3.3 divided by 8, that will be around I think 0.4125. okay, so it is 41.25 centimeters. So around 41 centimeter will be the correct answer. Okay, I hope this logic is clear. You can note it down if this was not clear to you previously. Okay, we just solved it, and the answer that we get is 0.4125. It will be 41 centimeters. Okay, over to the next question. So question 11 over here, the first question from the easy moderate category. Congratulations if you made it this far. Okay, you are patient enough, and like I always say, selection comes from patience. Okay, so anyways, let's continue with the question. So in this question, you are given a string of length L which is vibrating in its third overtone. You are supposed to find the maximum amplitude at L by 3. Okay, so first of all, third overtone means fourth harmonic. In case of and string which is fixed at both the ends, it is very analogous to your organ pipe which is open at both the ends, because in both the cases all the harmonics are present. Okay, so which basically means third overtone will be fourth harmonic, nth overtone will be n plus 1 harmonic. Now one more point to note is that the number of lobes equals the number of harmonic. Okay, number of lobes. Now in this here a wave will be formed, right? A standing wave will be formed. So the number of lobes in that wave will be equal to number of harmonics. Okay, so 4 lobes, 1 2 3 4. Okay, so 4 lobes are formed. So one more point to note, put it down in your copy. This is very useful. The number of lobes equals number of harmonics. Okay, now you can see that this distance, this entire distance is 2 lambda, right? You can see 2 wavelengths over here, 1 wavelength, 2 wavelength, right? So this entire distance is 2 lambda, or some of you might remember it this way, that distance between two nodes is L by 2. So L by 2, L by 2, L by 2, L by 2. 4 into L by 2, which is 2 lambda, right? Or basically you can see 2 wavelengths over there, 1 and 2. So 2 lambda. So this length of that string is nothing but 2 lambda. Okay, fine. Now let's write the equation of standing wave, which is y equals a sine kx into cos omega t. Okay, so I wrote the equation of the standing wave. Remember this was in fact question of your BITSAT 2020. They had asked you to just state the equation of your standing wave. Okay, so this is a question in itself. Okay, so anything of this format, sine and cos can be flipped, the phase difference can be also plugged in. So this is not a general equation. You can remember this is just a special case, okay, of standing wave like this. Okay, now we want the maximum amplitude. So what I will do, I will already consider that this factor favors. Okay, this factor favors. What do I mean by that? I mean that this value will be 1. Okay, this factor already favors. Okay, so I'll consider that. So in order to find the maximum amplitude at L by 3. Now we are supposed to find the maximum amplitude at L by 3. Okay, so first of all we know that length corresponds to 2 lambda. This length is 2 lambda. Then for L by 3 it will be 2 lambda by 3. Okay, all clear? Length corresponds to 2 lambda, L by 3. For L by 3 it will be 2 lambda by 3. Okay, so just substitute the values over here. K will be 2 pi by lambda, and we want the amplitude at a distance L by 3, right, which corresponds to 2 lambda by 3. So I'll just plug in that value. I'll write 1 over here. Okay, so plug in that value in place of x, put this, right? This is the place at which we want the amplitude. Okay, so it will be 2 lambda by 3, right? So 2 lambda by 3. So lambda cancels. You get y equals a sine 4 pi by 3. Okay, what is this 4 pi by 3? 4 pi by 3. Let's convert it into degrees, into 180 by pi. 3 6 are 4 6 are 24. So 240. So I can write it as 270 minus, I can write it as a into sine of 270 minus 30, right? 240 can be written as 270 minus 30, which is in the third quadrant, right? 270 minus 30, third quadrant. So it will be negative. Here also you can see that you are supposed to find the amplitude at L by 3. So somewhere over here maybe, right? So the amplitude will come negative, but we are just concerned about the value. Okay, so that will be minus a into cos of 30, right? Sine of 270 minus theta is minus cos theta. Okay, minus cos theta, minus cos 30. So minus a into cos 30. Cos 30 is half, no, cos 30 is root 3 by 2, right? So minus root 3a by 2. So option C is the correct choice. I hope the approach is clear. You have noted down the point. Let's move to the next question now. So question 12 over here, you can see that this question is directly from Doppler's effect. Okay, so in this question you have a stationary observer, a source which is moving with a speed of 19.4 meters per second at an angle of 60 degrees with respect to the ground. The frequency, the original frequency emitted of the waves emitted by the source is given as 100 hertz. You are supposed to find the observed frequency or the apparent frequency. Velocity of the sound in air is also given as 330 meters per second. Okay, so the first thing that you are supposed to do is to resolve this velocity. Okay, resolve it in two components. So this along the ground, along the horizontal will be 19.4 into cos 60, right? Cos 60. Along the horizontal it will be cos 60, which is half. And along the vertical, okay, perpendicular to the ground, you'll have 19.4 into sine 60, which is root 3 by 2. Okay, now the important point to note over here is that the perpendicular component will not contribute to change in frequency. Okay, the perpendicular component will not contribute to any change in the frequency, right? Because there is no approach and no separation. It is just the perpendicular component of velocity, right? Here you can see approach happening. In this case, you can see approach happening, right? So this component, there is no approach or no separation. It remains at a constant distance with respect to observer, right? So this velocity component will not contribute to any change in frequency. Okay, the only component contributing is the one which is approaching. Okay, so you can make a note that whenever you have velocity in some oblique direction, you can break it into components, one towards the observer, one towards or away from the observer, and one perpendicular to the observer. Okay, moving parallel to the observer. The component which is parallel to the observer will not have any effect on the apparent frequency. I just repeat the gist of it. The component which is parallel or perpendicular the component which is parallel to the observer will not have any effect on the apparent frequency. Okay, important point to note over here. So the only component contributing is this one. Okay, which is, you can cancel that out, 9.7. okay, so 9.7 meters per second. Okay, now we can use the Doppler's formula. So apparent frequency or the observed frequency will be given as V by V, and here it is the original frequency, right? So V, if you see the observer is at rest, so plus 0, right? And this is approaching, right? This is approaching, the source is approaching, it is trying to increase the frequency, right? So it is trying to increase the frequency, which means here there will be a minus sign. It is trying to decrease the denominator in order to increase the frequency, right? Source is approaching, it is trying to increase the frequency, which means it is decreasing the denominator. So minus of the speed. Okay, so minus of 9.7. So V is 330 divided by 330 minus 9.7 into the actual frequency, which is 100. And after solving this, I know it is a bit calculative, but after solving this by some maybe you can do some approximations here and there. After solving this, the answer that you are supposed to get is 103 hertz. Okay, so question 13 over here. In this question you have a stationary observer and you have two tuning forks, 1 and 2, each with a natural frequency of 340 hertz. One tuning fork you are going to move towards the observer with a speed u. The other tuning fork you are going to move away from the observer with the same speed u. Okay, so same speed but opposite direction. Okay, the observer here 3 bits per second. So how does he hear the bits? First of all, it is due to the change in their apparent change in their initial frequencies, change in their original frequencies. Here you can see that in the case 1, the apparent frequency will increase, right? The tuning fork is approaching the observer, so the frequency will increase, right? So here in this case frequency increase, and here in this case the apparent frequency will decrease, right? It's moving away from the observer. Okay, so there is a difference in their frequencies. Okay, there is a difference developed in their frequencies due to their motion. Okay, and due to which he hears those bits. Okay, So you can imagine it this way, that this will increase, right? The frequency of this, suppose it becomes 342, okay, and this will become 339, suppose. Okay, so if you subtract these values, you'll get 3. So that's why he's hearing those 3 bits, okay? Because this value increases, this decreases, the gap between them increases. So there is basically a difference in their frequencies. That's why he is hearing those bits. Okay, so that's the reason for hearing those bits. Anyways, you are asked for the velocity with which you are moving those tuning forks. Okay, so let's apply Doppler's effect for case 1, for tuning fork 1 and tuning fork 2. This is a very, very important question. You are supposed to note some things over here. So let's dive into it straight. Okay, so F A. So the apparent frequency will be V divided by, will be V. Now in case 1, the frequency is increasing, right? The apparent frequency is more, so the denominator, this velocity, is trying to decrease, right? It will be V minus U. The denominator will decrease, so that the frequency, the apparent frequency, is more. Okay, I hope that is clear. V minus U. Okay, the denominator will decrease in order to increase the apparent frequency. In case 2, you have some of you might just by heart the Doppler's formula. If you do it that way, well and good, but if you use logic, this is how you are supposed to think about it. Okay, and in the second case, let's write it as F dash A. Okay, so in that case, it will be V, observer at rest, so need not worry about that, and it will try to increase the denominator, right? So V plus U, because it's moving away from the observer, so it's the apparent frequency will be more, sorry, the apparent frequency will be less, right? It's moving away from the observer. Okay, so F original. Now you are supposed to find delta F, right? Delta F is the thing, the difference is the thing which is causing the bits. Okay, so delta F equals 3. That is the thing that we are going to use. So delta F, this one is higher, right? This one is bigger, this one is smaller, right? 342. This one is bigger, this one is smaller. This is approaching, this is bigger. Okay, so F of A minus F dash of A equal to 3. Okay, the change in their frequency is 3. That's why he is hearing 3 bits. So let's substitute. So you can take things common from here. V into F naught can be taken common, so you'll be left with 1 by V minus U divided by minus 1 divided by V plus U. Okay, that will give you 3. So let's write it over here. You'll get V into F naught, and here you'll get V plus U minus V plus U, right? That will give you 2. You can solve it. You'll get 2U by V square minus U square using identity. Okay, so I need some more space to solve it. Now remember this assumption, we are going to use it somewhere. Okay. Now I'll take V square common in the denominator, so I'll get V F naught into 2U divided by V square common in the denominator, 1 minus U by V the whole square. Okay, so this V and V can get cancelled, so you get 2U F naught by V. Now you can see that this ratio U by V is almost 0, right? Because you know that U, the velocity with which you are moving the tuning fork, is very much less than the velocity of the wave, velocity of the sound in the air. Okay, so due to this assumption, this ratio will almost tend to 0, right? This will be almost equal to 0, and 1 minus 0, that will be 1. So the final answer that you get is 2U F naught by V. Okay, I want you to remember it in a general way, that delta F equals 2U F naught by V. Okay, delta F is equal to 2U F naught by G whenever this assumption holds. Okay, remember with the assumption. Okay, delta F, the change in frequency, equals 2U F naught by V whenever U is very, very much less than V. Okay, so now let's solve it. So what do we get? The delta F in this case was 3, right? 3 beats per second. So the difference in their frequency was 3. So 3 equals 2U F naught. The initial frequency was 340. in divided by the velocity of sound in air. So I can consider that as 340. Was that given in the question? I don't know. I think it was given in the question that the velocity of the velocity of sound in air is 340. So you can cancel this and you'll get that velocity of the tuning fork is 3 by 2, which is 1.5 meters per second. Okay, sorry if I didn't mention this. I think it was given that velocity of sound is 340 meters per second. Okay, so the correct answer is option A. Over to the next question. Note down this formula that delta F is 2u F naught by V. We are going to use it in next few questions. Okay, let's move to the next set of questions now. So question 14 over here, if you look at it closely, it is just the Xerox copy of your previous question. Okay, two tuning forks, same natural frequency, moving in opposite direction with the same velocity. The observer is stationary, delta F, you are supposed to find that delta F. It is also given that Vs is very much less than V. Okay, we just learned the formula for delta F in the previous problem, which is 2 u F naught by V. Right, they have just changed the notation over here. So in place of u, which is the velocity of your tuning fork, the velocity of the source, we are supposed to substitute Vs. Okay, so you can remember this formula actually, because this is a good way of remembering it. Okay, so 2Vs into V, here they have used n for frequency. Okay, they have used n for frequency. Okay, so 2Vs into n in place of F naught, and V is the same, right? So 2n Vs by V. Okay, so remember this formula. This is a good way of remembering it, because here you might forget that u is the velocity of the source, right? This is a good way of remembering it. 2 Vs n by V, or 2n Vs by V. Okay, where Vs is the velocity of the source and V is the velocity of your sound in air. Okay, I hope that is clear. Let's move to the next question. We'll also use this concept in the next question. So question 15 over here, this was asked in 2006. In this question you have an observer and a source. Okay, the observer is stationary, the source is moving with a velocity of 5 meters per second towards a wall. The wave frequency, the frequency of the waves emitted by the source is 256 hertz. Okay, the velocity of the sound in air is 330 meters per second. You are supposed to find the number of beats per second heard by the observer. First of all, why will that person hear bits? Okay, are there two different waves, two waves with different frequencies interacting over there? Actually there are, if you see. Okay, if you ask me, there are two waves interacting. Okay, so first wave is the wave which is directly coming from the source. Okay, one wave, and the second wave is the wave which is reflected from the wall. Okay, so these two waves are interacting and they are producing the bits. Okay, actually this question is very analogous to our question 13 and question 14. You can use in fact the same formula, because number of bits per second is nothing but delta F. So you can use the same formula 2n Vs by V over here, and the answer that you will get is around 7.7, and you can round it up to 8. Okay, place number of bits as a natural numbers. Okay, so here option D is the correct choice. But how can we apply this formula? This is something that you will tell me in the comment section. Elaborate your idea. Why can we use this formula? Okay, because in question 13 and 14, if you see, we had two tuning forks moving in opposite direction with the same frequency, whereas here we have just one source, right, and a wall over there. Okay, that is your hint. Okay, so tell me how or why can we use this formula in the comment section. The correct answer will receive a heart from me. Okay, this was your last question. I'll give you your homework question and then we'll wrap up with the class. Okay, so question 16 over here, this is your homework question. You can pause and take a screenshot if you wish to try it later. Okay, so that's all for today's class. I hope you enjoyed it. I'll see you soon in the next class. If you made it this far, why don't you subscribe? Okay, so stay home, stay safe, keep enjoying physics.